When you look up at the night sky, the universe appears perfectly still, a vast vacuum where nothing makes a sound and objects seem to drift at a glacial pace. But perfectly hidden within these deep fields of thousands of galaxies, a single flash occasionally erupts. For a few brief seconds, that one point of light outputs more energy than every other star in the observable universe combined. Welcome back to another epic journey. Recently, we asked our community about the largest stars, and this chart visualizes that massive scale. Our sun is entirely swallowed by red supergiants like Betelgeuse, which are dwarfed by cosmic titans like Stephenson 218. These massive structures require oceans of continuous nuclear fuel to keep from collapsing under their own immense weight. Eventually, that fuel runs out, and the surrounding fabric of space experiences the consequences. A star's death is the most violent trigger mechanism found in nature. When nuclear fusion stops, the outward pressure keeping the star inflated instantly drops to zero. Gravity takes over immediately, crushing millions of miles of outer plasma inward at a fraction of the speed of light. That unimaginable mass slams into the star's dense iron core and physically bounces off. The resulting rebound generates an unstoppable spherical shockwave that rips the star apart from the inside out. The expanding debris field blasts outward in all directions, carrying enough kinetic energy to sterilize dozens of neighboring star systems. This is a supernova. It releases more energy in seconds than our sun will in its entire 10 billion-year lifespan. Yet, in the hierarchy of cosmic destruction, this is merely the opening act. Because its energy spreads out in a perfect sphere, the intensity dilutes rapidly as it travels through the vacuum. This makes the supernova our baseline, a predictable 360-degree expansion of energy that sets the stage for far more lethal events. In stars of sufficient mass, the core bypasses the rebound entirely. Gravity overwhelms the internal pressure so completely that the matter continues its inward plunge, punching a hole in space-time to form a black hole. As the core collapses, intense magnetic fields trap the chaotic plasma, funneling it to the poles. It erupts as a gamma-ray burst, twin radiation jets accelerating to near light speed. Unlike a supernova's spherical spread, this forces energy into a narrow 2-degree beam. If one of these beams were to sweep across our solar system from thousands of light-years away, it would instantly strip away the Earth's ozone layer and incinerate the atmosphere. Gravity in these environments acts as a focusing lens, taking raw stellar energy and weaponizing it into targeted cosmic artillery. Even these concentrated beams originate from the death of a single star. To push the physics further, we look at the interactions between two ultra-dense neutron stars, the solid remnants left behind by past supernovas. Locked in a gravitational dance, these two massive cores slowly bleed off energy. Their orbits decay, pulling them closer together, as they accelerate toward a fraction of light speed. The precise moment of impact is so forceful, it sends physical ripples through space-pan itself. The mechanical friction of two solid, dead cores grinding into each other generates heat and light that dwarfs a standard stellar explosion. This specific type of collision creates a kilonova. The kinetic force is so severe that for a few fractions of a second, the local rules of atomic physics break down. The temperatures inside a kilonova reach billions of degrees. That heat is the only environment in the cosmos forceful enough to smash lighter atoms together and forge the universe's heaviest elements. This visual maps how that immense kinetic energy translates into matter. When the shockwaves from these collisions cool, they leave behind newly created atoms of gold and platinum. The heavy metals in your electronics and the jewelry you wear require this level of force to exist. The universe relies on its most terrifying acts of destruction to serve as the engines of creation. If you're fascinated by the mechanics of the universe, we recently asked our community, have you subscribed to Actual Space? If you haven't yet, join us by hitting that button. Before you go, let us know in the comments which topic you want to explore next: JWST discoveries, black holes, or alien news. See you out there.